Hey, hello guys, welcome, Vandanam, Namaskaram. Today we are going to see inverse trigonometry from class 12th. Okay, so before going into this topic, we have to first cover what is an inverse function is. Okay, so what's an inverse function? It's very simple. For an example, we have this ordered pair which is x comma y. Okay, so when you are applying, this is what the function is. Okay, this is what the f of x is, which is going to give you y. Okay, so we all know that x is the input, y is the output, y is the range, x is the domain. Okay, so the inverse of this total, okay, so the inverse, okay, for this function, the inverse is going to give you the ordered pair as y comma x. Okay, so the total ordered pair is going to be y comma x. So how can you write it as? Very simple. You can write it as f of inverse of y is going to give you x. Okay, f of inverse of y is going to give you x, right? So just it's inverse. Okay, I hope till now it's all clear. If it's not, we will be discussing a few sums. Then it'll be all clear. Okay, so here I'm having a sum which is f of x is equal to 3x plus 9. Okay, so this is what the sum is. We all know that. Now first we are going to apply the inverse for this. Okay, inverse for this total function. So f of x is going to be y is equal to write in another color. Okay, so y is equal to 3x plus 9. First what we have to do, we have to change their places. So in place of y you have to write x, and in place of x you have to write y. So x is equal to 3y plus 9. This is what now we have got, right? Okay, so you have to make this y as the subject. That means transpose everything towards the LHS. Okay, LHL, left hand side, LHS only. So x minus 9 whole divided by 3 is equal to y. Okay, so this is something that you have got, and this is what the inverse function is. So this is equal to f of inverse of x is equal to, okay, x minus 9 by 3. Okay, so this is what the inverse function of this total function. Okay, this function's inverse function is this one. So yeah, it's all something like that. Okay, so we will also do another sum, which is f of x is equal to x square minus 4. Okay, so how can we do this? First, y is equal to x square minus 4, right? Okay, now we have to change their places. So that means x is equal to y square minus 4. Now make y as a subject. Then that means y is equal to, y will be equal to x plus 4 whole root. Okay, so this is what its inverse is going to be. So you can write it as f of inverse of y is equal to, okay, f of inverse of y is equal to root over, sorry, x is equal to root over x plus 4. Okay, so right like this you can write it as. Okay, now we are going to discuss their graphs. So here remember that x will be converted into y and y will be converted into x, right? Okay, now we are going to deal with graphs. Okay, so how first, okay, I'm going to draw a graph. Okay, let us take any graph. We will consider just a straight line. Okay, just a straight line. So here it's going to be what? Let me consider this as 2 comma 0. Okay, so 2 comma 0 is what I've considered. Then the inverse of this graph will be how? Since I have no place, I'll be just drawing in this graph itself. Then how will be the inverse graph for this graph? I've said that this is what x and this is what y, so they'll be interchanging their place. So that means the inverse of this ordered pair is going to be 0 comma 2. Yes, right. So just plot the graph. It will be like this, which is 0, comma 2. Okay, so it's just the inverse. Also, we will be, yeah, so till now I hope everything is clear. Now we will be going into sine, cos, cosec, tan, cot, okay, sec, all these graphs. Totally there are, okay, first we will be starting with sine. Okay, so sine, okay, one important thing. We will be first going to inverse trigonometry. Okay, first we will be going to inverse trigonometry, then we will be coming to graphs trigonometry. I forgot that itself. Okay, so inverse trigonometry. What is this inverse trigonometry? First, what is trigonometry? Trigonometry is something that is going to give you, okay, when you are applying trigonometry, to a right angled triangle, this is perpendicular, right? So to the right angled triangle, okay, imagine this box as right angled triangle, okay, right angle or 90-degree. Okay, so right angled triangle, what it will be giving you? It will be giving you the ratio of their sides. But when you are applying inverse trigonometry, IT, okay, inverse trigonometry, it will be giving you the angle. Okay, it will be giving you the angle. For an example, oh god. Okay, so it's going to give you some angle. For an example, I will consider this as the theta. Okay, so no, for that you have to know first what is inverse trigonometry now. Oh god, what am I doing? I'm going to make it all tough. Okay, so it is going to give you some angle. This is what the basic thing is. Now we will be going to graphs. First we'll be dealing with sine theta. Okay, so sine theta graph. And already I've said, right, this is going to give you angle. That means the notation for inverse trigonometry. For trigonometry, how we will be writing? We'll be writing them as like sine theta, cos theta, right? Sine theta, cos theta, all these 6 trigonometric functions will be written like this. Then how will it be written? It will be written as, since it is going to give you the theta, so sine inverse x. Sine inverse of x is going to give you as theta. Here how we will be writing? We will be writing it as sine theta is going to give you x, but here it is written as sine inverse of x is going to give you theta. Okay. Okay, so this is what the sine theta is. We will be now going to draw the graph. This is not the sine theta. Now we are going to see sine theta. So first, what its domain is a dark color. So domain. Okay, domain and range. Okay, since this graph will be very small, if I consider these two as 1 and minus 2, I'm going to consider. I cannot write here, right? So if I write over there, it has minus 1 and 1, the total graph will be just between these two. It's something you cannot see through camera. So I will change this as minus 1 and plus 1. Okay, so let it be minus 1 and let it be plus 1. Okay, so first, what is the domain for this? It is going to be all real numbers. Okay, all real numbers. Then what its range is going to be? It's going to be from minus 1 to plus 1. Okay, so how will you do the graph? It's very simple. Already you have studied it from class 11th itself, right? So you are not supposed to draw the graph of sine theta out of this total range. So it's going to be like this. I think I'm drawing it in a very ugly way. Oh god. Oh god. Oh god. Okay. See, it's like a snake. Every trigonometric, literally every trigonometric graph is going to be like snake only. So it's like this. And see, what does it actually mean? It means that this is what the total x-axis is, right? So this is x dash, and this is going to be x. This is y dash, and this is going to be y. So this is what the total x-axis is, and we know that x-axis is something that has to be considered as the domain. So here you can give any value in this x-axis, but the output will be from +1 to -1 only. So that is what we are saying it as the range. Okay, so for an example, if I'm giving pi by 2 as the domain, okay, as the input, then it's, see, what's there for it over here? We are having here as +1. So that means when you're giving for this function, for the sine theta, pi by 2 as the input, then it is going to give you 1 as the output. Okay, so that's what it means. Okay, so we have completed now sine theta. Now we're going to cos theta. Cos theta and sin theta are very close friends. Okay, just they have some minor differences. Other than that, the domain is same, their range is same, and the graph is similar to each other, but that is not same. Okay, those two are not same, they are just similar to each other. So same thing I'm going to do here also. What I'm going to do is I'm going to consider, I'm going to first erase these two since the graph will be very small. Okay, -1 and then +1. Okay, I will write it. Okay, so what its domain is going to be? Its domain is going to be all real numbers. It's going to be all real numbers. Numbers is not required. Okay, so all real numbers. Then how about its range? Its range is going to be +1 to sorry. You have to always write the smallest number first, then the largest number. Okay, that's the rule. Don't ask me why like that. It should be written like that. Okay. So how will be its function? Sorry, how will be its graph? So here for this alone, you have to start from here. Then do the normal procedures. For some reason, drawing these graphs isn't such a small deal. Okay, so this is how it's going to be, and the same concept applies here also. So you can give any number from x-axis, that is what the domain is. You can give any number from the x-axis, and it's going to give you the resultant between +1 to -1, just like sine theta. Okay, so that's for cos theta. Now coming for tan theta. So tan theta is kind of different. What you have seen over here for sine theta is there, right? It is actually continuous. Okay, so it's actually continuous. That means there is no break over here. Okay, it is a continuous function. It's just, you can draw this total graph without lifting your pen, but I have to lift my pen since I'm not an artist. Okay, but you can just draw this total graph without lifting your pen, and it's something we will be studying in continuity and differentiability. Then it is actually odd function, and also it is periodic. That means it repeats. Okay, see, take this minus pi by 2 and this pi by 2. Okay, that is what this is clear, right? This is what is over here also. From here, no, take pi. Okay, take this pi. You are supposed to take from 0 to, oh god. Okay, so what I said was correct only. You have to actually take here and here. Okay, so the thing, every value from minus pi by 2 plus pi by 2, okay, it will be giving you some output, right? If you are giving input from minus pi by 2 plus pi by 2, it will be giving you some output, right? That is what will be repeating over here also. Okay, from this pi by 2 to this pi by 2. Okay, it will be same as this one. Here also be same as this one. Okay, it will be the same. There won't be any much difference. Okay, next is yeah. So cos also. So for cos, how it will be? There won't be any differences. There won't be any difference at all. It will be just the same. Okay, I said right. There won't be much difference. Sorry, that statement was wrong. There won't be any change at all. Okay, so then how about for cos? Cos will be from here to here. Okay, it will be repeating just like that. Segments. Okay, then how about tan? First we'll be drawing tan theta. See, we all know that tan will be reaching its own infinite value. Okay, its own infinite value. What is tan? Tan is going to be sine theta by cos theta, right? Okay, so when we all know that this cos theta should not be equal to 0. Okay, this cos theta should not be equal to 0. What will happen if it is 0? It will be reaching to the infinite point. Okay. So that means tan will be reaching to the infinite point. Cos theta will be 0 when it is pi by 2. Okay, when it is pi by 2, it is 0 only. See, at every pi by 2, it is having its value as 0 only. So whenever cos theta is actually at pi by 2, when theta is actually at pi by 2, then that means cos theta will be, okay, that means cos theta will be 0. So which makes, okay, so which makes tan theta, tan pi by 2 infinite. Okay, infinite. Okay, so we can say that there will be breaks. From this statement itself, you can easily say that there will be breaks at every pi by 2 of tan theta, because it will be reaching to the infinite, and we cannot plot the graph at infinite because infinite is indefinite. No one knows what is infinite. Okay, we haven't found. If you are a very genius, then find what is infinite. Infinite is a number which cannot be, we cannot even have it. Okay. So at every pi by 2, that means at every 90 degree, tan theta will be reaching to its own infinite value. We can, okay, from this we can say that tan theta graph will be broken. Okay, it is not continuous here, it is discontinuous, because at every pi by 2 it's going to infinite. So you can write it as like this. Okay, so it will be just going like this. And also, the graph of x cube is very similar. Okay, the graph of x cube will be very similar to this graph. Once my teacher was drawing this x cube graph, and then when I came to know that, okay, these two are very similar to each other. Okay, so yeah, it is discontinuous. Coming to its characteristics, it is discontinuous, and it is also periodic. Okay, it is also periodic. See, it repeats from minus pi by 2 plus pi by 2. It just repeats as such. And one thing I forgot to say in everywhere, that's going to be here I've said it is odd function, right? Okay, so here it is odd function. What does it mean? That means if in case sine theta is there, right? Sine theta is negative, so that means this degree is going to be minus something. For example, it can be minus 30 degrees, it can be minus 60 degrees, it can be minus 90 degrees, it can be anything. So it is going to be equal to minus sine theta. Okay, but whereas for cos theta, it's not like that. Okay, so for cos theta, first what it is actually continuous. Okay, and also then what else is there? It is even function. From graph itself, actually we should find whether it is even function or odd function, but I have searched it literally everywhere in YouTube, but I cannot understand how to determine whether a function is even or odd. Okay, I cannot understand that total concept. Okay, so it is actually even function, which means cos theta, and if the theta is actually negative, then that will be going to give you as positive only. Okay, you can just neglect that negative sign itself, because okay, that we will be seeing later. Tan theta, it is actually odd. Okay, yeah, it's actually odd. Okay, so this was for tan theta s. Now hereafter I have to make one thing. Now still we have three more things to discuss. Now what we are going to see is we are going to see sec theta. Sec, or what shall we see? Cosec, cosec we will see first. Okay, so cosec theta. Cosec theta, what is actually cosec theta? Cosec theta is the exact inverse of sin theta. Inverse in the sense it's just the reciprocal. Okay, it's not the inverse, it's just the reciprocal. So that means for sin theta, you have to draw everything. Okay, everything between plus 1 to minus 1. But for cosec theta, you have to draw everything other than plus 1 to minus 1. That means you are not supposed to draw this graph between this place and this place. Okay, you are not at all supposed to draw, because see, sin theta is like this, right? How will be sin theta? Oh god, my graphing sense is very bad. It's very awful. Oh no, this is also not that good. Okay, anyways, consider this as the sin theta graph. Okay. For me, drawing in the paper itself is very tough, and in this drawing over a board is very tough for me. Okay, so there will be inverse of this. Okay, just this graph will be inverse. That means you are not like, don't imagine that this graph will be like this at all. Something over top and something over down. It will not be like that. We have already broken this total, right? So we have broken here, 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 and also we have broken here. Okay, what I'm going to do is you are just supposed to put the reciprocal. Okay, you are just supposed to put the reciprocal of this total thing. Here it will be, sorry. For sin theta, what you have to do is, it's over here. Okay, so just put this inverse, just put this inverse, just put this inverse. Yeah. 1 second. Yeah, this is wrong. Hmm? I think I'm messing things up. Here. Wait, I've done something wrong over here. Going like this and going top, then intersecting. No. Minus pi by 2 down. 3 pi by 2, it will be up and down. Oh, yes. Oh, shit. Okay. Now it is okay. Now it makes all sense. Okay, so it will be over here like this. And here also there are breaks. Over here. Okay, then where else? Here also the break is there, here also the break is there, and here also the break is there. Okay, now you might think over cos theta, where have we segregated this sort of thing for cos theta? Sorry, for sin theta we have to see now. Okay, so for sin theta, where have we segregated? Here only now. Then you might ask me like, then we have to put the inverse of this one, right? Well, it's not like that. You are not supposed to put inverse of this one. First, you have to notice all these following things that I'm about to say. Cosec theta. Cosec theta is actually inverse of what? Sin theta now. Inverse of sin theta. Okay, so when will be sin theta 0? Sorry, when will be the total sin theta itself will be 0? It will be 0 at every, when sin theta is equal to 0 degrees. Okay, when it is equal to 0 degrees, it will be 0. So that means it will be giving you infinite. It is going to be infinite. And also, what are the other angles that it's going to be 0? See, here it is 0, here at pi it's 0, at 2 pi it's 0. So at every pi, sin theta is going to be 0. Okay, at every pi, sin theta is going to be 0, right? Okay, so just look. So that means over here, cosec theta will be reaching to the infinite point. Over here also, cosec theta will be reaching to the infinite point. Over here also, cosec theta will be reaching to the infinite point. Over here also, cosec theta will be reaching to the infinite point. Okay, so first you have to break like that. Then you have to put inverse of that. Okay, and this is sin theta's graph. So this total thing itself is not required. This sin theta graph is not required. In order to explain, I've written it like that. Okay, so how it is? It's domain and range we have to see now. What is domain? First, always we have to know that what is the domain. Domain is something that you can give it as an input. Okay, and you have to see range also. Domain, you can give every domain. Okay, you can give everything except pi. Okay, you can give everything except pi. Yeah. Except this pi. See, here you cannot give, this also you cannot give as the domain because it will be reaching to the infinite point. So all real numbers minus n pi. Okay, you are not supposed to give this as the input. And where n you can take it as any integer. Okay, n belongs to integer. Okay, n belongs to integers. Then how about range? See, it's over here, it's like this, it's like this, it's like this. Like that, it's over the opposite directions. You can also say this as take over here. Okay, so for range, okay, well, here you might think range is very complicated. Not like that at all. All you have to do is you have to take the union minus infinite comma minus 1. Okay, minus 1 union with plus 1 comma plus infinite. Okay, so this is what range is, none other than the y-axis. Okay, so from minus infinite to minus 1 it is there. See, here it is there, here it is there, right? And also over here it is there. So from plus 1 to plus infinite it is there. Okay, so this is what the range is. I've actually taken notes everything in my phone, and I'm not that much I cannot even see what's something I've taken. That's the problem. Okay, next is sec theta. No, sec theta we have not completed. Okay, so sec theta we have not completed. For sec theta, it is what? It is just the inverse of cos theta. So sec theta is equal to 1 by cos theta, right? One by cos theta, right? So cos theta will be reaching to its zero at where? Let me see here. At pi by 2, pi by 2, pi by 2. Okay. See, cos theta is going to reach its infinite at every pi by 2. Hmm. So that means 1 by cos n pi by 2 will take. Is going to give you infinite. So sec theta will be having its break at every pi by 2. That you can say from here itself. Okay. Now, and also one more thing. Since cos theta is fully from plus 1 to minus 1, here it will not be from plus 1 to minus 1. Just like how sine and cos are best friends, like that cosec and sec are best friends. Okay. So, how will be the sine theta's graph? First, we will be drawing sine theta's graph. Sine theta will have no breaks. I don't know why, but it looks very wrong. Okay. See, whatever I'm drawing over here is not cos theta's graph. Cos theta's graph is something that I've drawn here very beautifully in a very amazing way for my level. So that's what the correct thing is. Okay. So I think one second we'll change this color alone. Frame red color, okay na? Okay, red color indicates problem. Okay, so red color indicates problem. So here we will be having problem. So life itself is full of problem. Like that here itself, here we are having a lot of problems. So now we have to put inverse of this. So inverse means it will be just like this. Oh god, it's very light. You cannot see. Because even neither can I see. Okay, so it's going to be like this. And for it, it's going to be like this. Then no. So I said nah, it's looking wrong. Yeah. I said right. It's looking very wrong. It's looking very wrong. Okay, so now it's looking correct. Then it will be like this. Okay, so like this when we are supposed to draw the graphs, and I'm very sorry. Here everything is correct. Okay, here see sine theta is very correct. That I'm sure. Okay, cos theta. Here alone I'm making some mistakes. Okay. Next is the last but not the least. That's going to be our cot theta. Okay, it's very sweaty over here. If I on the AC or the fan, you cannot hear me perfectly. It's just inverse of tan theta. Okay, it is just the inverse of tan theta. Okay, so tan theta will be 0 at what are the points? Okay, what are the points that tan theta is going to reach? It's 1 by infinite is 1 by infinite is 0, na? Okay, so you can also write this as cos theta by sin theta, right? Okay, so sin theta will be reaching at 0 at what? At every pi. At every pi. Sin theta will be reaching its own 0. Okay, see, sin theta at every pi it's just going to reach its 0. So whenever cos pi whole divided by sin pi is, it's going to give you infinite. Okay, so at every pi you are going to face danger. Oh, I did not understand all these just now. Well, teaching you, I even came to know. Okay, so yeah, pi at every pi. Pi also will be in this y-axis. Okay. Now, what you are supposed to do is you are supposed to put the graph of tan theta. First, I will be putting the graph of tan theta since these two are inverse of each other. Okay. No, tan theta I cannot plot here. It will be totally confusing then if I plot tan theta. Okay. See, tan theta is like this. Then the inverse of tan theta will be like this. If tan theta is like this, the reciprocal, not inverse, sorry, the reciprocal will be like this, right? Okay. And also, if it is over here, okay, if it is over here, then the location should be shifted to here. Wait. We will ask to the smart board itself. Flip. See, it has got flipped. So that is where the reciprocal is. OMG, how smart am I? So put that graph over here. Oh. It's like far. Okay. Note this blue line is not supposed to touch this red line. Okay, those two are repelling in nature. Okay. Now we are again going to inverse trigonometry. There is one condition to be in this inverse. Okay, to be an inverse function, there is one important condition. That is, it should be bijective in nature. It should be bijective in nature. Then only it can be inverse. Okay, it should be bijective in nature. So what is a bijective thing? Oh. Okay, so bijective in nature. So that means it should be okay onto and then 1 1. Okay, 1 1 and onto both should be there. 1 1 and then onto. Okay, both should be there. What does it mean? Both onto 1 1 all these. Okay, what does it mean? It means 1 1 now for one domain. Sorry, for one domain, one range. Okay. Yeah. Okay. So to be an inverse function, it has to be bijective. Then to be a bijective, it should be 1 1. Okay, it should be 1 1 function. And then also it should be an onto function. Then how will you be checking it? For onto, it's very simple. Okay, every x-axis should be corresponding to one y-axis. That means every x-axis should be having its own range at y-axis. So it's very simple. Then how about 1 1 1 1? We are having one thing that's known as some test. Okay, you are going to follow some test in order to determine whether it is a function. First you have to check whether it is a function or not, then you have to check whether it is 1 1 or not. So in order to determine whether it is a function or not, what you have to do is you have to do vertical line test. Then for here you have to do horizontal line test. Horizontal line test. Okay, which means we will be saying that also. So 1 1 na horizontal for function. If in order to determine whether it is a function or not, you have to do vertical line test. First we have to check whether it is a function or not, so we have to go with vertical line test. So we will be taking which color? Pink color or Yeah, pink color is the thing that I have not, red color is the thing that I have not used. Okay. So first you have to check whether it is a function or not. So what you have to do, you have to check whether it is a function or not by using vertical line test. Okay. So draw one vertical line. Just see at how many points it's being intersected. Over here, over here, over here, and over here. Today there are 4 different points where it is being intersected. Okay, ma'am? So, but according to vertical line test, the functional graph, okay, the graph of a function can be any function, but it has to be intersected at only one point, okay, at any one point. But here there are totally 4 different points where this total graph is being intersected. That means this is not at all, this is a function, okay, so this is a function. Sorry, we have to do vertical line test. OMG, what am I doing? I'm doing some other thing. Vertical line test. I have drawn a horizontal line. Okay, sorry. First, you have to check whether it is a function or not. How will you check whether it is a function or not? Draw some lines. Okay, vertical lines. But make sure that those lines are straight. Okay, if they are perpendicular to this x-axis, that will be very good. Okay, so now what you have to do is, according to vertical line test, only one point. Okay, the function's graph can intersect this line at only one point. It should intersect at only one point. Then it is known as function. See, only at one point it's being intersected. Okay, so at only one point it is being intersected. So you can say that this is a function. Then, in order to determine whether it is 1, 1 or it is not 1, 1, what you have to do is you have to put a line like this. Okay, a line like this. Okay, ma'am. So here it should be intersecting only at one point. But see, how many points are they totally? It has got intersected at 4 to 5 points there, right? There will be infinite points actually. So since only this much I've taken from minus pi to plus 2 pi, from minus 2 pi to plus 2 pi, only we have taken, so we have got only limited amount of points of intersection, but there will be infinite points of intersection. Okay, so that means this is not 1, 1. If it is not 1, 1, then how can it be a trigonometric function? Okay, then how can it be a then how can it be an inverse trigonometric function? Then how in the whole world did they figure out a chapter called as inverse trigonometry, and how did they do all those concepts? Okay, all these things is which we are not going to use in our real life anyway. All these, and how were they able to submit this headache to us as book? Okay, as a chapter in a book. It is actually, they have cut this sine theta's total graph. Okay, they have cut this graph into pieces, and then they have did this test. Then it's okay. Then it is following. Okay, then it is following. Okay, so this is how normally others in other YouTube channels they have explained. But I have another way. Okay, this is something that it's okay. Okay, we will also see another thing. So what I'm going to do is, this is domain and this is what ranges. Okay, so A, B, C, D, E, F, G, H, I. Okay, so you'll take this. Like this we have taken, right? So this is 1, 1. Okay, this is 1, 1 only, but this is not onto. Okay, but this is not onto function. Now if you put inverse for this, okay, so if you are putting inverse for this, then how it will be? What I said, this has to come as domain and this has to come as the range, right? Then E, F, G, H, I, A, B, C and D. Okay, but see, 1 is being left out. Okay, 1 is being left out. That means I is being left out, but nothing should be left out as in the domain part. Okay, so nothing should be left out in the domain part. That means it's not even a function. This cannot at all be a function. So, see, it's actually 1, 1, but it is not onto. So it's not able to be in its inverse 1. Okay, now we will check for 1, 1 onto. Okay, one second. Yeah, so yeah, it's very simple, right? Just like this you have to do. So whenever it is both, okay, when it is both, now we will be checking for when it is both 1, 1 and onto. A, B, C, D, E, F. See, now it is both 1 1 and on 2. Now you can actually easily do its own inverse. D, E, F and A, B, C. See, now if you are doing inverse, now it's a function only. So that means, what did I say over here for this sine theta thing? If you cut it out, okay, here it is periodic, right? So if you cut it out, it repeats over here. So what they did is they have first cut it over here, okay? They have first cut this one graph. Okay, so first they have cut this graph over here, and then they did this total inverse line, vertical line test in order to determine whether it is a function or not. Okay, so vertical line test done. Okay, very pakka, super. So first we are going to consider only this part. Okay, I think, okay, we will draw over here. Okay, for sine theta we'll draw over here. That will be perfect. Oh. Okay, so now what we are going to do is we are going to draw the inverse of sine theta. Yeah, I know that. Well, I'm not prepared like that at all for them. Okay, because all these I've got from online. Okay, from Google. But for this I have to draw. Okay. So first of all, we are going to see. I've said, right, you have to cut at 2 points of sine theta. Okay, it's periodic. Those 2 points you have to take. What are they? They are minus pi by 2 to pi by 2. Okay. Before that, I will say to you one important point, that is, how will you remember these two other points? Very simple. That is, first you have to check. Yeah, every point, okay, literally every point will be near to the origin, or at least they will be on the origin, or they will be at least near to the origin, and mostly they will be positive only. Okay, that means they will be like this itself, like this side only. Okay, they won't be negative. Either they will be on the origin or they will be this side of the origin. Okay, and second is, it will be exactly, see, what you have to do is, yeah, if this is what the graph is, you have to just split it into lines, okay, into straight lines. Like that, if I just splitting them into straight lines, then definitely, then this point will be 1 point, okay, one end of the line will be at -1 and one end of the line will be at +1. Okay, for an example, now let us take for cos theta. See, now you have to split it like straight lines. Okay, just split it like this, then one will be at +1 and one will be at -1. Okay, then for tan, just like this you can take it. Okay, it's which is in the on the origin. Here it will be one at plus infinite and another will be at minus infinite. Just take a line like this. Okay, here it is on the origin, so you are supposed to take this one. Then for cosec, how about cosec? Very simple. You can take any segment, and I said that mostly it will be positive. So from the origin, I'm going to take this as the segment. Then how about sec also, which is on the origin itself? We are going to take this particular point. Okay, so how about first we'll draw a sine theta's graph. Okay, +1, -1 it is. So the graph of sine theta from here to here, how it will be? One. Okay, just like snake. Okay, see, this is what you are going to take. Okay, now what you are supposed to do is, you have to put the inverse of this. What I'm going to draw here only, it is known as the inverse graph. Okay, for inverse graph of sine theta. So you have taken this. Now you have to put inverse for this sin theta. How will you put inverse for sin theta? It's actually quite simple, you know. Everything that is in the x-axis should be going like this. Okay, see, whatever you have drawn over here, like this, okay, should be going like this. Just the inverse. Okay, so I've just tilted it. Grab this. Okay, imagine that this total thing as some sort of like this. You can imagine it as. Okay, this is what the graph is. Okay, now this is what x-axis and this is what the y-axis is. Just tilt it like this. You will be getting the inverse of sin theta. Okay, so whatever is like this, just make it like this. You'll be getting it. So here only I'm going to use my techie brain. I've got this. Oh, sorry. Oh shit. Okay. We will draw them in a one shot. Oh god, I'm such a bad artist. Now I'm a very good artist. Okay, so which is like this. Okay, which is like this. Now we are going to convert it like this. Now, like this to like this. Okay, so now how it is? It is like this now. So turn it, turn it, turn it, turn it, turn it, turn it. Then we are going to get like this. No, like this only like this much you have to see. Now it is over here. Okay, so just 90 degrees you are supposed to change. So like this you will be getting the graph. Okay. First it is like this only now. Oh sorry, one thing we have to do before that. First you have to flip it out. Okay, first I'm going to flip this like this. Okay, wait. Clone. I'm going to put it over this itself. Okay, so first you have to flip it out. Okay, so after flipping, now you turn like this. Now you are supposed to turn it 90 degrees. Okay, so now after flipping only you are supposed to turn it 90 degrees. Okay, I will redo what I've just now done. Okay, so see, there is one thing like this. Okay, so this is what the sin theta's graph is. Okay, sin theta's that particular parts, sin theta's parts graph is this one only. Okay, first what you have to do, you have to flip it. Okay, flip. If you are flipping now, exactly like this it will be coming. Okay, exactly like this it will be coming. Now after flipping, you have to steer it out. That means you have to just turn it. Okay, 90 degrees you are supposed to turn. Then you will be getting something like this. Okay, now you put it over here. Now you can put it over here. Okay, ma. And one thing we will do, we will erase all these. How techie am I? I'm very proud of myself. Okay, so now this one only. Okay, so this one only will be minus pi by 2. And in this one will be plus pi by 2. Okay, now this one will be plus pi by 2. Then this one will be the origin. Now this one will be plus 1. This one will be minus 1. I know we have restricted domain, we have restricted range, all those things we will be seeing. Before that, we will be going with this techie idea. Then we will be writing all those things. Okay, so this is what for cos theta is. For cos theta, from this part to this part, you are supposed to take, right? Okay. So for cos theta, and also with paper also you can do this. Very simple. What you have to do is you have to draw a graph. For an example, if this is the page, for an example, if you are just drawing this graph, okay, like this you are drawing, okay, it can be any graph. I don't have anything. So like this, what I'm drawing over here is chord graph. Okay, chord graph I've drawn over here. What you have to do is, you have to flip it like this. Then since this marker is not that much good heavy, if you are getting a heavy marker like permanent marker, and if you are drawing on the paper and if you fold it like this, then there will be a trace that will be, you can see over here, this side you can see, right? So that will be the flip graph. Okay, that will be the flip. Then you have to turn it 90 degrees. Okay, that will be the total inverse graph itself. Okay, the total inverse graph itself will be like this. When you are seeing itself, it will be totally flipped and it will be turned to 90 degrees. Okay. Now what we are going to do is we are going to do for cos. Okay, so for cos inverse of x is equal to theta. Okay, so here will be it's actually, it is completely with that side, right? It is completely with right side. Okay, so it's completely based on right side. Okay, so this is what it will be, what, 0, 0. Okay, so from here we have to start. It will be plus 1 and here I'll take it as minus 1. Okay, so then here it will be minus pi by 2. Then here it will be pi. Okay, well, it has come in blue color, but I will change. Okay, so it has got a little bit out. Okay, so this is how the graph is going to be. Now what we have to do, we have to again use our techie brain. Flip it out. Okay, first before that I will clone it out. Clone. Okay, so this is what cos theta, that particular segment's graph is. First we have to flip it out, then you will be getting this. Then you have to turn it 90 degrees. Oh shit. Okay, now what you have to do is, you have to turn it 90 degrees. After turning it 90 degrees, you'll be getting like this infinite symbol. You'll be getting. Put it over here. Okay, not at the origin. Sorry, above the origin. Okay, above the origin. Then that means it will be like this itself. It will be like that itself. Above the origin only, you have to draw this. Then I'll put it over here. Okay, so now what I've got is, I've got cos inverse graph. Okay, like this only, this also. Perfect. So how, what point will it be? This will be plus 1. Okay, then this will be minus 1. Okay, then this will be the origin. This will be what? Pi. This will be pi by 2. Okay, so this is how you are going to draw cos inverse graph. Then coming to tan inverse graph. Okay, so first we have to draw tan theta's graph. Minus pi by 2, then plus pi by 2. Okay, then what I'm going to do is, I'm going to okay, now what I'm going to do is, okay, so I've got this particular segment. Tan theta's graph you have to draw. Oh, first before that we will write that this. Tan inverse of x is equal to theta. Now after writing this, okay, so this is what the tan theta's graph is. Now as usual you have to do this. Before that, as usual, I will erase this. I have no idea why I have spent unnecessary time on this. Okay, so first we have to clone this, keep it over this, overlapping. Okay, first we have to flip it. Okay, then you have to turn it 90 degrees. See, again you are getting that same infinite symbol only. Remember this point. Literally for sine, cos and tan, you will be getting this infinite symbol. Okay, like this one infinite symbol you will be getting. Okay, so just place it out over here. Okay. Well, since you are not going to have smartboard over your examination paper, instead of examination paper, you are not going to use a smartboard and you are not going to write, you are going to write it on the paper. Then how will you write over there? Very simple. First take this part, then take this part, then take these parts. Okay, this part is over y-axis, this part is over x-axis, this part is over again y-axis. Whatever the part is over y-axis, just convert those parts. Okay, just convert those parts into x-axis. See, this is enjoying its own part in y-axis. Now this part is now wait. Yeah, sorry. This part is totally in x-axis. Okay, it's more in x-axis. Like that, you have to keep it. Okay, then just you have to put more that in y-axis. Now see, it's more in y-axis, but here it's more in x-axis. I don't think you all can get it. What's more in x-axis? What's more like? What I'm coming to say is x-axis is horizontal, right? So this part is also more horizontal than these parts. Than these parts, this part is more horizontal. But in the inverse, the part which is more horizontal will be more vertical. Okay, the part which is more vertical will be more horizontal in the inverse. Okay, so you all got me? Perfect. Now, this part is going to be pi by 2. This part is going to be minus pi by 2. This part is going to be 0 comma 0. Then what else do we have? Okay, yeah, that's it. That's it. This part is going to be minus infinite. This part is going to be plus infinite. This part is also going to be plus infinite. This part is going to be minus infinite. Okay, so this is how we are going to draw for tan. Then for cosec, what part I'm going to consider in cosec is I'm going to consider this one. Okay, this one as the part. So it's from 0 to pi. Okay, see, for cos we have considered from 0 to pi, but whereas for sine we have considered. Okay, so now we are going to see cosec inverse. Okay, so till now we have seen sine, cos inverse and tan inverse. Now we are proceeding with cosec inverse. So before that, you all know that this is what the graph of cosec is. Okay, so over here, what are those segments that I'm going to choose? That's something you have to notice. What is the rule? First, what is the main rule? Okay, in order to be one function, or in order to be a function itself, see, in order to be function we have to first draw a vertical line, or in order to be one function we have to draw horizontal lines. Okay, so we all know that every graph of trigonometry, okay, every graph of trigonometry is what? A function only. This one we know that, but we don't know whether they are one to one or not. Okay, see, when you are taking just sec inverse, or when you are taking just cosec inverse, or just tan, sorry, not inverse, when you are taking just sine, just cos, just tan, all these just without any inverse function, then they are not one function. You have to classify them into segments. For an example, I have to take a particular segment in this total graph that makes this cosec, okay, this cosec as 1. So what part can I take? I have already said that take the part that is very nearer or that is very close to the origin. So here I can select this part, right? This part and then this part. Okay, now draw a horizontal line. Okay, now draw a horizontal line. Now just you are taking this one and then this one, right? So this part you have taken and also this arc you have taken. Now when you are drawing this line, then in that case it intersects. Okay, from here to here only you have to take. Okay, here to here and also here to here. It intersects only at one point. One line intersects at only one point. So this makes that this cosec is 1 in this particular segment. Okay, so I can also draw the same thing at pi by 2. Okay, at where? At pi by 2, minus pi by 2. Okay, and also at positive pi by 2. At negative pi by 2 and at positive pi by 2 only we have taken. See, okay, so cosec is what? It is inverse of sine. For sine, where we have taken, what is the segment of sine that we have taken? Check, it is also pi by 2 only. Okay, then for cos, what we have taken? Pi, right? Okay, so for cos, what we have taken pi. You can take any segment of pi. You can take this segment, you can take this segment, but the thing is, when you're drawing a horizontal line, it must intersect only one point of the total arc or of the total function. Okay, so this line itself is a representation of this cos theta. So when you're drawing a horizontal line, what should be there? only one point intersection should be there. Then only it will be one function. So that is why we have taken only this part. I have explained all of them, but since I'm refilming this video because I've made a small mistake over there, I'm saying this all again. So that means for cos from origin from 0 to pi you have taken, right? Then for sec where you have to take. For sec also you can take, very well you can take from 0 to pi. See, the reciprocal of cos is what sec, right? So if you have taken for cos 0 to pi, now then for sec also you can take from 0 to pi itself. For sine if you have taken from minus pi by 2 plus pi by 2, now then for cosec also you can take from minus pi by 2 plus pi by 2 itself. Okay, it's just a remembering point that I have given you so that you can remember them. Okay, so how it will be, how the graph is from here. Okay, so from exactly from minus 1 to here and from plus 1 to above, right? So I'm also going to mark minus 1 plus 1 okay. So again I will check it one time. From here to, from minus 1 to here it is going like this. So we can draw for this like this, right? So exactly take this minus 1 point, exactly over here is where minus 1 is. I'm sorry, this pi by 2 is hiding it. Okay, exactly this is what the point is. Here only you have to start, then you can scroll down. Then where will be minus pi by 2? Okay. Then how about this one? Here it starts from plus pi by 2 this half. Okay, so from here you can just extend it. Like this, only it will be going. Okay. So very well, very good. We have taken how many parts? Minus pi by 2 plus 1 minus 1 plus pi by 2. So that means even in the inverse of cosec theta, I have not even written that. Cosec inverse x uses theta. This is how we have to represent. Okay. So this one is there. So first of all, you have to do what? You have to flip it. Okay, flip in sense how? First, wait. We will first mark it. Here in y-axis what we have plus 1 and minus 1. That means in x-axis over here only plus 1 and minus 1 will be there, right? So here we will be having minus 1. Here we will be having plus 1. Okay, so here what do we have in the x-axis? Minus pi by 2 to plus pi by 2, right? So over here in the y, okay, so on the y-axis we will be having minus pi by 2 and also plus pi by 2 we will be having. Okay, so these are the parts that we have. We know that graph can never lie between plus 1 to minus 1. So you can just make an arc. Yes, right. So graph can never flow from plus 1 to minus 1. Okay. And also graph cannot go. Okay. See, for the video purpose, I'm going to make this pi by 2 a little bit more top. That means I'm going to write it still more in upper part. So here pi by 2. Okay. So here this one also I'm going to represent over here. Okay. Minus pi by 2. Okay, so here the line, okay, this graph does not come inside what? Inside this part itself, but over here this is what you have taken now. Okay, so here totally where the graph is going to be lying is over this part and this part. Okay, so these are those two different segments where graph is going to lie. Okay, now we will see how it is going to. So first what we have to do, we have to select it. We will be cloning it and we will go overlap. Okay, so this is what the segment is. First what we have to do, we have to flip it. Okay, so you have flipped. Then after flipping, what you have to do, you have to turn it exactly 90 degrees. Turn it 90 degrees. Okay, so you have turned it 90 degrees. Now, just we will place it over here. Exactly at pi by 2, you will be having a graph like this. Okay, so then for this, how will it be? Okay, so select the same graph, will be cloning and keep on this itself. Okay, so first what we have to do, we have to flip it 90 degrees. So you have to just flip it. That means if something is like this now, then you have to make it like this. Just like dosa. Okay, if something is like this now, then just make it like this. See, this was like this now, make it like this. Papa, no. Okay, so this is like this. Now what we are going to do is, we are going to flip it. So yeah, just like dosa it came, right? Now what you have to do, you have to turn it 90 degrees. Okay, so now we have to turn it 90 degrees, just like this, and place it over here. Okay, just place it over here. That's it. So you have got the graph. Okay, so you have got the graph. So how are you going to remember this? And one point that I have to say over here, this part, okay, this is where the starting point of this graph, and for this is where the starting point of this graph is. Okay, so if you draw a line like this, if you draw a line like this, what it is the graph of our what? Our sine. What sine? Sorry, yeah, it is our sine inverse graph. Where is our sine inverse graph? We have, see, we have this graph. We have this graph, right? Then also check this graph. Check this graph. Sine inverse graph. Okay, sine inverse graph is this graph, and this graph is cosec inverse graph. So the exact starting point of cosec inverse graph is the exact terminal point of sine inverse graph. You can very, yes, thank you. Even it has got accepted. Okay, even it has accepted. Okay, so even it said that yes, it is correct. Okay, now we are going to seek. So seek, what you are going to choose? You are going to see. You are going to choose this particular part. So if you are choosing this particular part, now let us draw that horizontal line test. Okay, horizontal line test, horizontal line test. If you are testing it, okay, only one point intersection is happening, so that means this is going to be a 1-1 function. Okay, so this is going to be 1-1 function, right? Okay. So I'm going to take and draw this exact same thing. One thing that you have to notice is from origin to pi. Okay, from origin to pi only we have chosen. Okay, so origin is over here. What is this? Secant is. No? Okay, so origin, even in origin, what will be happening? Over -1 and +1, nothing will be there. Okay, check. -1 and then where is this? -1 to +1. Okay, -1 to +1, nothing will be there. This is actually cos inverse. Okay, sorry, this is actually cos graph. This is cos graph, and this is what sec graph. This light green color is what sec graph. This one is what sec graph. Okay, so this part we have chosen, so it's going to be like this. Over here, if I take it as pi. First, we will mark the place where it will not be. No. Okay. So that means how its graph is going to be. Just check. It's going like this and it's coming like this. So from here, okay, from here we are going to take, and like this it is going to be for here. Like this one, the graph is going to be. Well, you might ask, where is the domain? Where is the restricted domain? Where is the range? All those. First, we will be seeing all these graphs. Then, after seeing these graphs, then we will be at last checking domain, codomain, range, restricted, all those things. Okay, ma'am. So we have chosen this. What do we have? +1, -1, and pi, right? So we are going to have the same thing over this inverse also. The sec inverse x also. This is actually the restricted part of sec x. Okay, sorry, this is the restricted part of sec theta is going to be x. This graph is sec theta is equal to x. Restricted graph. Well, the graph that we are going to draw here, everywhere we have drawn, right? That is what the sec inverse x is equal to theta graph. Okay. So how is sec inverse going to be? Okay, so well, normally I have this so that I won't make any mistakes, because I'm saying to you all, right, if I make a mistake, you all will be making the same mistake. Okay. So we are going to mark. Okay, we are going to mark only pi. See, what do we have? What do we have to mark over here? That we are going to check. This can come down. Over y-axis, what do we have? We have -1 and +1, right? Okay, so we have -1 and +1 over y-axis. That means this -1 and +1 is going to be on x-axis. So if that is on x-axis, so here it will be. Okay, these two are those respective points. So here it will be -1, here it will be +1. Okay, pi is there. Pi is on the positive side of x-axis. That means over here it will be positive side on y-axis. Okay, so I'm going to draw over here. See, pi. Okay. See, from where to where actually graph is there? From this part. Okay, so from -1 like this it is there. Yes, right. From -1 like this it is there. Well, beyond pi there is no, but before pi we are having. So pi is there. Between these two paths there won't be any graph. Between these two paths there won't be any graph, just like here. We don't have any graph, right? Just like that, we won't be having any graph over here also. Okay, so we don't have graph over there, so that particular area is being eliminated so that you will not draw a graph over there. Okay, next is in one area. Okay, in one area. Now what I'm going to do is, in one area, not only in one area. Okay, so for video purpose, so that you can see very clearly, we will draw this pi on the top. Okay, we'll draw this pi on the top. Okay, actually if you notice, both of them, okay, this arc and this arc, both of them are on the positive side of x-axis. So when you're drawing them, where you have to draw? On the positive side of y-axis only. Okay, not on the positive side of y-axis, because here they are on x-axis, on the positive side of x-axis. So when you're drawing here, they both, okay, must be presented. Wait, here they are on positive side of what? X-axis. Okay, they are positive side of x-axis. That means when you are drawing over here, they have to be on positive side of y-axis. Since they are over here positive side of x-axis, here they have to be in the positive side of y-axis. That is what the reciprocal, right? That is what the inverse trigonometry, not reciprocal. That is what the inverse, right? So if here it is x, then here it will be y. So that is why I have drawn this. Okay, this one above. Over here you can have wherever you want. And also if you notice, here, okay, so this is what y-axis is, this is what the x-axis is, we know that. So on top of x-axis we are having 1, that means on the positive side of y-axis we are having this one. I'm just saying the way so that you can put this without seeing the book itself. Okay, on the positive side of y-axis we are having 1, and on the negative side of y-axis we are having 1. So which is on the negative side of y-axis, which is on the negative side of y-axis must be presented over the negative side of x-axis. Okay, must be presented on the negative side of x-axis. Do not write, since these two are opposite, okay, we have to put this on negative side of x-axis and we have to put this on positive side of x-axis. Not like that. Just x has to be replaced by y, and y has to be replaced by the x. Okay, that's the difference. So since this is on the negative side of y-axis, we have to put it on this side, which is in the negative side of what? Of x-axis. Okay, here it is negative side of y-axis, negative side of x-axis. Okay, normally what you have to do, first you have to put those up. So that means we will first clone it. Okay, like this you will have. Now what you have to do, you have to flip it just like that. If you're flipping it now, then you will be getting an arc like this. Look, see, you are getting an arc like this. Yes, right, you are getting an arc just like this. Okay, so now I've got something like this. We have to turn it exactly 90 degrees. So if you're turning it 90 degrees, see, I'm giving you shortcuts so that you can do that in your examination. Okay, well, we don't have smart boards in our examination papers. Instead of our examination additional sheets, we won't have these, right? So you can just say, okay, so flipping it, just put with your brain itself, it will be coming to you. Okay, so where we have to draw, here we have to draw. So from here, exactly on this point it will be starting. So since over here I have drawn it like very neatly, I'm going to erase it, I'm going to draw it with hands itself. Okay, with bare hands. With bare hands. Okay, so here it starts and it goes like this. Okay. So then how about this? Okay, then how about this? Nothing crossed over here x, sorry, over pi. We don't have any area. So even if this is what the pi is, okay, if this is what the pi is, nothing will be crossing over here. Okay, nothing will be over here and nothing will be over here. So don't make any mistake of drawing your graph over here or over here. OMG, even I don't know that these many things are there. While explaining only, even I'm noticing, okay, so these many things that we can say. Okay, next is on the positive y-axis. That has to be represented on the positive x-axis. So take it, okay, take it. First we will be cloning it. We'll keep it on here itself. First what you have to do, you have to first flip it. So flipping it will be like this. Okay, so you have got like this. Now you have to turn it exactly 90 degrees. You turned it 90 degrees. And you have got this. So where you have to draw, how you have to put, here you have to start it from here, because here this graph has started from the y-axis. Okay, on y-axis only this has started itself. Well, this has started on the pi line. Okay, on the pi line it has started, but here it has started on the y-axis. So that means here it has to start on x-axis only. Remember this point here on it. Okay, so over here, just like this, it will be going on. Okay, so this is how you have got these graphs. Next is cot. Well, I don't know already I have explained this cot thing or not. Okay, if I have explained already this cot inverse, now then just skip it. I cannot edit, I cannot spend any time for editing at all. I have to read. So no bitings. So yeah, now we are going to see cot inverse. Okay, so cot inverse of x is going to give us theta. Okay, so what you are going to do, you are going to consider a particular segment over here. What segment you can consider? Any segments, but I have preferred to, I have already said that always take anything that is nearer to the origin and also to the positive side. That means to the positive side of x-axis. So this is what the segment that you are going to take. Okay, the segment that you are going to choose is this one. Okay, so you have got the segment which is from 0 to pi. Okay, see from, sorry, pi, 0 to pi maybe, correct. So here to here, origin to pi. Over here, let us imagine pi is there, here pi by 2 is there. Okay, so that means how will be graph starting? For tan theta, it will be like this. Okay, but since we are drawing for cot theta, it will be starting from here. Okay, well, before that we will first draw this infinite line. Okay, that line also has a name, but I forgot it. I've forgotten. No bitings, Papa. Just look, it's biting me like I bite my leg piece. Oh, my grill. Okay. Karma is a boomerang. Okay, so from here to here only it is going to be right. So take it. No! Oh god, I don't know why I cannot draw it neatly. Okay, so we have got this particular segment. Very easy. Tan and cot is very easy. I said right, tan is like Nagaraja, so cot will be like Nagarani. First what you have to do, you have to take, okay, first we'll mark these points. First choose where it is. It is on the positive side of x-axis. It is on the positive side of x-axis. So over here where it will be on the positive side of y-axis. Yes, right, it will be on the positive side of y-axis. So now, okay, I have represented like this. What do we have over here? We have pi by 2 and pi. So pi by 2 is going to be there and pi is going to be there. So since it is on the positive x line, here I have drawn it on the positive y line. Okay. So it starts from where? From the positive y-axis. That means here the graph is going to start from the positive x-axis. Okay, and it ends in the negative y-axis. That means here the graph is going to end in the negative x-axis. Okay, so other than that, the rule applies the same. The graph will not cross over this one. Kilicha koda taandadu. Okay, so it will not cross over this particular line. So exactly same thing we are going to do. How are you going to flip this? Okay, how are you going to flip this? Okay, so first before flipping, I will even draw by flipping itself. Then you will say, oh no. Okay, so yeah, it is like this now. Then put it like this, or you can also put it like this. Anyways, in either side it is dosa only. Dosa is dosa. Okay, so we will draw like this. Wait. I will show you. First with computer technology we'll see, then with my technology we'll see. You are biting me like anything. Okay, see, you have got like this only. Okay, like this if you are putting also the same way. I will show how. Okay, so this is how we are having. This is how we are having. Okay, now we are flipping it like this. Now then the graph will be like this. Okay, then the graph will be like this. Okay, so if you are flipping it now, then it will be like this. Wait. It will be like this. Sorry. If you are flipping it like this, then it will be like this. If you are flipping it like this also, it will be like this only. If you are flipping it like this also, it will be like this. If you are flipping it like this also, it will be like this only. Okay. Anyways, dosa is dosa only. No matter whether you are turning it upside down or downside up. Okay. Experience as a chef. Okay. So coming out of this one, now cloning. You will keep. Okay. Wait. So now we will be doing with computer thing itself. And also you have to turn 90 degrees. Turning 90 degrees is very simple. Over your examination paper, what you have to do, you have to just turn your paper 90 degrees. Then you will be getting the total graph itself. So, wait. Oh God. Why am I doing like this? Clone, overlap it. After overlapping it, okay, this is what chord is. Now, do like this. Then turn it exactly 90 degrees. So, like this you have got. So, place this point, okay, place this one point over here. Ta-da, you got it. You got it. Over nowhere I've mentioned x and x dash, but it's okay. My heart says you have to mention. Okay, see, and I said that you have to turn them, right? I said that you have to tilt them, right? But don't tilt, don't put over here x, and also don't put over here x dash. Don't do that mistake. Only you have to tilt the graph. Don't tilt this total graph, these quadrants itself. That is completely wrong. Just tilt these lines which is inside the graph. Don't tilt the graph itself. Okay? Now, what we are going to do is, now we are going to see a restricted domain, we are going to see restricted, all those things, okay? Domain, range, all these. For sign, we have already written, okay? For sign, what is this? Domain is this one, all real numbers, you can give all real numbers. And the range is going to be from -1 to +1. Okay. No, Papa, no. Isn't he very cute today? Okay. So, over here, for this one, for this restricted graph and for sine inverse. This is what sine inverse is. This is just the restricted graph of sine. Okay. So this is very similar to sine because it is just a part of sine. A slice of pizza. So this is going to be domain. Range. What is domain? Domain is x-axis. We all know that. So what is over here on x-axis? We have, okay, what do we have on x-axis? It ends from -π/2 +π/2, right? So that means the total domain itself is going to be what? -π/2 to +π/2. That's it. And you're going to choose also -π/2 to +π/2. That means it will be closed brackets. Okay, this point also you're going to take, and this point also you're going to take. So that means it's going to be closed brackets -π/2 to +π/2. Okay, -π/2 comma π/2. Next is, what is this range? See, range is always y-axis, which is from -1 to +1. Always write smaller number before, then write larger number. That is what the rule of intervals is. Okay, representation of intervals. So -1 comma +1. You have got this one. Okay, for this restricted thing you have got. Now, how about this inverse? Okay, this is the restricted part. This is what the inverse part is. Okay, so how about this inverse? Already I've started to walk like a grandfather. My backbone pains. So domain and then the range. Now we will use our brain. If we have one, we can use one. Which is our, this is minus 1. Okay, so this is minus 1. Okay, so this is what our domain is. The x-axis is what our domain is. As I said that please don't interchange x and y. So this is going to be x dash, this is going to be x, this is going to be y, and this is going to be y dash. Okay, so x dash and x. So this is what the input that you're going to give. So it will be from minus 1 to plus 1. Over here I have plus 1. So minus 1 comma plus 1. Okay, then how about the range? Range is from minus pi by 2 plus pi by 2. Okay, one thing you can do. What is that? Change this domain and range. Just interchange them. You will be getting this. See, put this over here, put this over here. Ta-da! You got your domain and range. Abracadabra. So much of Netflix is doing. Okay, so for cos theta, this is what the graph is. So this is what the restricted cos theta. Ouch! It pains. It pains. It pains. Okay, so this is what the restricted cos graph is going to be. So how the domain and ranges? We will see that. Okay, domain, then range. Okay, and also how can you write this? Okay, how can you write this? This you can write it like also in the form of inequalities, right? So in terms of inequalities, you can write them like this. Domain of sine inverse and range of sine inverse. If you want the restricted part, what you have to do? Put this over here and put this over here, and you'll be getting this. Just all you have to do is to interchange it. Okay, so here it is minus 1 comma plus 1. Here it is minus pi by 2. Okay, here minus is there. Minus pi by 2 comma plus pi by 2. Just like that, only literally for everything we are going to see, one by one you will be seeing. Okay. Because in options you should not get confusion. I'm saying like a teacher that or like a student who gets sent him in every maths exam, but only I know about my maths marks. Okay. So this is domain and this is what the range is. So domain, what is domain? From 0 to what? To pi. Okay, to pi we have. So we can say 0 is also included, comma pi is also included. So then how about the range? Minus 1 to plus 1. So it is minus 1 comma plus 1. Ta-da, ta-da, ta-da. You got this. You got this. You got this. Next is this domain. And then also this range. Just interchange them. We will be getting it. If you want, we will also check over here. Cos inverse, right? See, minus 1 to plus 1 is what we have. 0 to pi only we have here. Okay, so interchange them. So that means it will be minus 1 comma plus 1, because this is what we have here. It is plus 1. Then range, what is range? From 0 to pi. Okay, 0 comma pi is what the range that we have. Okay. Next is what we have tan. So I've already written for tan domain and range over here, which is 2n plus 1. Okay, 2n plus 1 into pi by 2. Where n is an integer. Okay, it can be any integer. It can be 0. Integer now you know, right? Okay. So how about its domain and how about its range? Here what you can do, here how you have to write is domain and the range. Okay, with this graph part we will be completing this total video, as I have to also film continuity today itself. So with this one we will be stopping this graph. That means with this domain, this restricted domain and all these concepts. Then in the next video we will be seeing properties. Okay, property 1 is there, property 2 is there, property 3 is there, and with that we can close the chapter of trigonometry. Okay, no sums will be done. You all know, right? So yeah. So domain means what? From minus pi by 2 plus pi by 2, but here minus pi by 2 and plus pi by 2 are not included. So which means minus pi by 2 comma plus pi by 2. If you want, we can check also for tan inverse 6. Okay, so that is domain now. So here it will be for tan inverse, it will be range. Okay, so for tan inverse, where it is? Yeah, minus pi by 2 plus pi by 2, where you can see there is no equality or equal to symbol. Okay, so from this itself, we can easily conclude that what I've written over there is correct. What I've written over there is correct. Huh. So this one you can write like these two ways. Like see, over y-axis every number is there. So you can write like minus infinite comma plus infinite, like this also you can write. Sorry. Okay. Or you can also write it as all real numbers. It's your wish. Okay, it's based on your wish only. So then how about over here? It's just going to be, it's reciprocal. It's going to be range, and this is going to be domain. Huh. So it's just reciprocal now. From all real numbers over here. So what is that? Domain is going to be real numbers. Over here from minus pi by 2 plus pi by 2, where no equal to symbol is there. So that means open bracket only you have to use. No bitings. Sometimes my bird does give me kiss in the form of bitings, but it pains very much. Yes, right. Yes, right. Okay. Next is cos theta. So for cos theta, how you are going to have, this is what you have. Okay, so here after we will just directly jump. Okay, we will directly jump to here itself, because we know that just interchange those two. So why to write each and every time and why to write it again? So we will just directly write the domain and range of cos inverse itself. Okay, cos inverse itself. For this, if you want, you can just put the inverse. Okay, sorry, just the interchangement. Domain. Oh God, no biting, I said. Okay, so domain, then the range. Okay, see over here it might be little bit confusing for you, not only for you, for me also, as even I have not prepared this domain and range. I'm just saying this, but I know everything is correct because we can also intercheck them. Okay, if we want, we can also intercheck them. I have the clip over here, right? Okay, first we will do by our own, then we will at last check it. Okay, don't worry, with this video you will not going, you will not be dissatisfied with this video. Everything what I'm saying will be correct, and I will be checking them. If I have doubt now, I will edit it. Don't worry. Okay, so domain. So domain. What is domain? X-axis only. Our domain is. So from, what you can say? Exactly from minus pi by 2 plus pi by 2 is there, but 0 you will not get. Okay. Sorry. Domain is x-axis. Now what am I writing? Okay. From minus infinite to minus 1, then from plus 1 to plus infinite, that is what your domain is going to be. Yes, right. So from over here minus infinite, from here it starts, and over here then you have to put union and plus 1 to plus infinite. Okay, plus infinite, that is what you are going to have. You will check it over here. I hope you all can get it. Oh, what were we discussing? What was that function? Cosec inverse, right? Okay, so for cosec inverse, what is for cosec inverse? Yeah, so what does this mean? X is less than or equal to minus 1. That means minus infinite, comma, okay, open bracket, always for infinite, open bracket, comma, minus 1, close bracket. For this union, or means what? Union, and means what? Intersection. Yeah, I can remember that very well. Okay, or means union, and means intersection. So, or, X is always greater than or equal to 1. So, I can write this as equal to symbol is there. Please know that equal to. Okay, so 1 comma plus infinite. So you have got this one only, that one only. I have also said there. So now we will be checking over there. Minus infinite comma minus 1 union plus 1 comma plus infinite, and also make sure that you are putting close bracket for minus 1 and plus 1, as these two are included over this cosec inverse x is equal to theta. Next is range. Okay, what is this range, your honor? I don't know why am I using this, your honor. Maybe I might be submitted to the court very soon. Okay, so next is range. What is this range? Range is y-axis. So from minus pi by 2 to plus pi by 2 is there, but remember you will never get 0. You will never get 0 over here. So you will never get 0 in this. You will be getting 0, but only where? At infinite. And infinite is indefinite. You cannot get that. Infinite is a number that we don't know. So you can say that from minus pi by 2 plus pi by 2, but excluding 0. Okay, but excluding 0. You will also check that for once. See, that is what even they have given here. Excluding 0. Okay, OMG, I'm becoming good in mathematics. I cannot believe it. Okay, so from minus pi by 2 plus pi by 2, but excluding 0. We will write that. How can you write? You can write this in the indeterminate form itself. That means from, yeah, so here minus pi by 2 and plus pi by 2 are included. So minus pi by 2 comma plus pi by 2 whole divided. Okay, so yeah, so over here, but you have to neglect this 0. Okay, you have to take that 0 out. No. Okay, next is our seek. Come, go. Okay, we will erase this. Okay, as these are said by me for so that you can all understand that one very clearly. Okay, domain. What color was I using there? Yellowish, right? Domain, then the range. Okay. What is this x-axis? X-axis is this one. So from what is this particular point? Minus 1. Okay, minus 1 to it will be going till minus infinite. Okay, so minus infinite to minus 1. Over here, what it is? It is plus 1 to plus infinite, right? Plus 1 to plus infinite. So you can write it as minus infinite, comma plus 1 is also included. So plus 1 union with, sorry, minus 1. Here it should be minus 1. Minus 1 plus 1, comma plus infinite. Okay, plus infinite. This is what its domain is going to be. Next, how about its range? Everything is positive. Okay, everything is positive and they all terminate. Okay, they all terminate, not terminates. They all terminate at where? X. Okay, beyond X there is nothing. Yes, right. So we can say from 0 to X. Sorry, 0 to pi. 0 to pi. We will check that also one time. Yeah, so 0 to pi. Here it is 0 to pi, and over here equal to symbol is there. Over here I can see, I don't know whether you can see it or not. Here I can see equal to symbol is there. No bitings. Okay, so whatever I'm saying is correct only, you can believe me. Very proud of myself. So it's going to be from 0 to pi. 0 to pi. Okay, so you have got range. Next, after this, what you are going to do? We are going to see for cot. So cot inverse. So what is its domain and range? Domain and in range. What is its x-axis? This is what its x-axis is. Over x-axis, you can give anything. Okay, you can give anything. So it's going to be all real numbers. No, Papa. All real numbers. Okay, then how about range? No. Okay, so then how about range? Range you can give only from 0, okay, to 0 to pi. Okay, so from 0 to pi, we will check that also because it's very similar with the previous trigonometric function that we have discussed. Where is cot? Yeah, cot all real numbers and 0 to pi. Okay, it is going to be 0 is also included, pi is also included. Okay, now I'm going to show you one art, okay, the real art of trigonometry. So this is what the real art of trigonometry is. When you combine all the graphs, okay, when you combine all the graphs of inverse, sine inverse, cos inverse, tan inverse, cot inverse, sec inverse and cosec inverse, then you will be getting all these. Okay, see this color, okay, over here. This line is there, right? It is sine inverse. I will use some other color. This color is okay. So this is sine inverse of x is equal to theta. Okay. So over here, next is this particular color, which is cos inverse. Okay, which is cos inverse. So cos inverse of x is equal to theta. Next is tan inverse. So for tan inverse, this is what the color is. Okay. Tan inverse of x is equal to theta. Okay, next is cot inverse, which is this one. Okay, so cot inverse of x is equal to theta. Next is sec. Okay, so this one is what? Sec. So sec inverse of x is equal to theta. Then cosec. So this line is equal to cosec. Okay, so cosec inverse of x is equal to theta. Okay, so each and every line represents it, and we have seen all these lines only Okay, and see, exactly this is where the point. Okay, this is where the point. Now we will be seeing some other characteristics also. The point of sine is this one. Okay, the sine starts from here and ends at here, and also this is the place where this is what, this is cosec. Okay, so cosec starts and it ends. Okay, this is cosec. Cosec inverse of x is equal to theta. This is the place where it starts and then it ends. Okay, next this tan and cot we will be seeing. Okay, tan just goes. Okay, tan just goes, and it goes like this snake. Okay, and this also goes like this snake. Okay, it's yeah. So cot is Nagarani, tan is Nagaraja. Next is now we'll be seeing the cos also. This pink color line is there, right? So this is what the cos line is. Exactly the place where cos starts and ends is the place where sec starts and ends. Sec starts. Okay, this is where it starts and this is where it ends. So exactly here only sec starts and here also sec starts. So yeah, that's it. Okay, so that's it for this total today's video. Now we will be ending this video and we will be seeing in another amazing video. Till then, bye bye.